Today we're going to look at a related rates problem. 36 pi centimeters cubed of clay is being shaped on a pottery wheel. The clay is in the shape of a right circular cylinder. If the radius is decreasing at 1 centimeter per second, how fast is the height changing when the radius is 3 centimeters? So the first thing we want to do is identify the important pieces of this problem. Right away we see that we have 36 pi centimeters cubed. We also have right circular cylinder. We know that the radius is decreasing at 1 centimeter per second, and we want to know about the height when the radius is 3 centimeters. So before we start diving into all the details, we should definitely draw a picture to get our heads around the problem. So it's being shaped on a pottery wheel into a right circular cylinder. So we have something that looks like this. Now, we don't know what the height or the radius are going to be, and so whenever we're dealing with a related rates problem, we want to leave any variables that could change as variables. We don't want to lock them in to a specific value. So the radius should be r, and the height should be h. Now we want to write out the rates we're given and the rates we're looking for. So it says that the radius is decreasing at 1 centimeter per second. This means that dr dt is equal to minus 1 centimeter per second. And we want to know how fast the height is changing. Or we're looking for dh dt, specifically when the radius is 3. We don't know what this rate is, but we're going to look for it. And now, we need to somehow incorporate the 36 pi centimeters. What can we do with that information? Well, the formula for the volume of a right circular cylinder is going to be pi r squared times h. Now we know that this has to be equal to 36 pi. And that's not going to change throughout the entire problem because it's a lump of clay that's being shaped. The shape is being changed, either made taller or shorter, but the same amount of clay is there, 36 pi. And so we can cancel the pi's and find that radius squared times h has to be equal to 36. Okay, so we look at this problem and we want to find out dh dt. What can we do? Well, it doesn't look like we can solve this equation anymore. It doesn't look like we can change in any other variables. So now would be a good time to differentiate. So we're going to want to differentiate this equation, and we'll do it implicitly with respect to t. This means we are going to need to use the product rule. So using the product rule, we're going to get 2r dr dt times h plus r squared dh dt equals 0, because the derivative of a constant is always 0. Now, looking at this equation we have here, r is known because the radius is 3. dr dt is known as minus 1. H is unknown, so we're going to need to do some work on h. But again, r squared is known, and dh dt is the rate we're looking for. So our last problem here is going to be to figure out what is h. Now, I've written out our equations. The first one here being the related rates, where we're still looking to find that h. But I've also written out the initial equation we started with, r squared times h equals 36. We know that r is supposed to be 3 from the original question. And so if we substitute 3 in for r, times h equals 36, we can use algebra to show that h has to be equal to 4. Now we have all the information we need to solve the question. Going back to our equation here, we can sub in 2 times 3 times r is decreasing at -1. H we just found was 4 plus 3 squared times dh dt, are unknown. So now we want to work out all this algebra and isolate for dh dt. So here we're going to get 2 times 3 times 4, which is going to give us minus 24, plus 9 dh dt equals 0. And so if we solve for dh dt, we get 24 over 9, which simplifies to 8 over 3. Now to answer the question in words, we were asked how fast the height was changing, and so we can say the height is increasing because our rate is positive, increasing at a rate of 8 over 3, and we need to remember our units. It is centimeters per second. That is how you solve the related rate problem. Thanks for watching.